TG. This is lesson 9.4, section 5.4, and algebra 2b. The title of this lesson is Arithmetic Series. What I'd like to do to start you off here is I'd like to have you take the first three problems in your notes and simply add all of the numbers that are listed together. As you can see, we have a sequence of numbers. There are patterns, so look for shortcuts in which to add all the numbers that are in front of you together, and I'll hit pause, and when you're done, we'll show you a way of putting the sum of all these numbers together in the fastest possible way. Okay, welcome back. As you can see in the first three problems, I simply put plus signs in my sequence of numbers, and we actually wanted you to add all those numbers up. Now, instead of entering in my calculator left to right, I grouped them. I grouped the first two in sequence 1, the 4 and 39. I grouped the 9 and 34. I grouped 14 and 29, and I grouped 19 and 24. And I found those groupings were all the same. They're all 43, and I had 4 of them. So instead, I just multiplied 4 times 43. In the second sequence, I've got negative 1 and negative 13 is negative 14. Negative 3 and negative 11 is negative 14. Negative 5 and negative 9 is negative 14. But I've got a negative 7 left over. So I essentially have 3.5 pairs that are all the same. We end up with, and if I multiply negative 14 times 3.5, I end up with negative 49. And the same holds true with number 3. So as you can see, if this is a arithmetic sequence to start with, there is a way of adding all the numbers together. Now, why is that important? Well, this lesson's about not arithmetic sequences, but arithmetic series. Arithmetic series is just simply an expression of the sum of terms, which we just did, of a sequence. A series can be finite or infinite. Infinite meaning it never stops. The ones up top there are finite arithmetic series. They're finite because they end. They're a series because we're adding all the numbers together, and they're arithmetic because each have a distinct difference. So that's what we're working with in this lesson. We're going to show you how to essentially add a series of numbers together if it's arithmetic, and we're going to introduce a new symbol, a symbol that you never found before. But first, let's look at a formula that allows you to find the sum of a finite sequence. In my process of adding all these numbers together, I hope to show you that formula where all you have to do is pair the first and last terms together, and that will be the same as the second to the last. And then that's what this formula does. It basically, S sub n is the sum of the finite series. A sub 1 is the first term. A sub n is the last term, and n is equal to the number of terms. So let's use this formula in one of the top problems. Let's pick the first one. We'll just do it for number 1. If I look at number 1, I go back to the formula. S sub n will be my sum equals the number of terms is the top number, n. Let's count how many terms do I have. 1, 2, 3, 4, 5, 6, 7, 8. And then you're going to put that on top of n. Or n, 8 divided by 2, I should say. N is on top. This tells you how many pairs that we have. Remember when I did it up here, I grouped the first and last two, the last one and the first one together to get 43. That's a pair, and basically there's going to be 4 of those. So what this part of the formula does is it tells me how many of those pairs there are. And then this part of the formula, a sub 1 is the first term, which is 4, and then the last term is 39. 4 plus 39, and this essentially tells you what each pair adds up to be. So if you end up with 43 here times 4, which is the same answer as we got up here, 43 times 4, or 172. So that becomes our sum of our series. If you put in an odd number, that would be the case here in number 2. If we put an odd number for the number of terms, you would get 3.5. And then your inside the parentheses would give you negative 14, which gives you a negative 49 for an answer. So that's how we find the sum of a finite, sum meaning add, of a finite series. Now, the next part of this lesson involves a new type of notation, which is called summation notation. There's a new symbol here. You've never seen this before. It's called sigma. And when you see this sigma notation, it's this E Greek symbol that looks like an E. It's a Greek capital letter, actually. It means sum or summation notation. And what they'll do with these types of problems is they'll simply give you limits. These are the terms that we're going to be working with. When it says n is equal to 3 to 8, that means we're working with terms 3 through 8. And then, so in number 2, the terms are from 0 to 4. Those are our limits. And with each of these, you can actually create a series of numbers. So let's begin by first, in number 1, showing you what this whole summation notation represents as far as a arithmetic series. The first thing I'm going to do is I'm going to put 3 in for n. Now if I put 3 in for n, you can see it's just 1. That's my first number in my series. Then I put 4 in for n, I'll get 2. And I put 5 in for n, I'll get 3. And we'll do that all the way up to 8. And we're on, so we put the 3 in for n, and then we all the way up, that's the third term, all the way up to 8. So 3, 4, 5, 6, 7, 8. Basically, that's what you have here. Instead of writing out the whole series, this summation notation is a representation of that. Then if you have to, you can use the formula to find the sum, the summation of this series. Up here, we'll use this formula, the number of terms. So S of n equals the number of terms, 1, 2, 3, 4, 5, 6, divided by, it says up here, n divided by 2. So 6 divided by 2 times, in parentheses, a sub 1 plus a sub n. So our first term was 1, our last term's 8. So we end up with 3 times 9, which is 27. So this equals 27. That's our final answer. It's simply the sum of this finite series. Now what I'd like to have you do is pause and try and see if you can find the sum of number 2. Find the summation notation from n equals 0 to 4 with this expression representing our explicit formula. I'll put it on pause and let you finish. Welcome. Here's the results for this summation notation problem, which represents a series of arithmetic series of terms. As you can see, this time what I did was I put the limits from 0 to 4 underneath, so you can see actually you're just plugging these in to the expression provided. And as I did that, 0 became 0, 1 became 2/3, 2 became 4/3, 3 became 6/3. I left that as 6/3 because I knew I was going to I would need a common denominator instead of 2, and that's 8/3. Then using my formula to find the sum of an arithmetic series, we put in the number of terms here, right here, this is how many terms we have, 5, divided by 2, that's how many pairs we have. And then the first and last terms are 0 plus 8/3, which is 8/3. If you multiply those, the 5/2 times 8/3, you'll get your sum, which is our final answer of 6 2/3. So now what I'd like to have you do is flip the notes over, and in the second video, first I'd like to have you try the problems that are listed there. And in the second video, we'll go through your results. Thank you.